In this video, we are going to learn about measures of center. Let's begin. So, what are measures of center? A measure of center is a way of summarizing the data by providing a central point of data. So, what do we mean by that? It's like if you have a lot of data points, for example, lots of numbers, let's say the height of kids in a 6th grade classroom, you're going to have a lot of data points there, a lot of heights, a lot of different heights. The center of data, or one measure of center, is it's like a single number to kind of give someone an idea about like roughly how tall a 6th grader in a class would be. So you may have heard like finding the average height or the mean height. Those are examples of the center of data. If you play sports, you might have heard of like average points per game in a game of basketball. So things like that. Those are single numbers. They are a measure of center because let's say some basketball player makes 10 points one night and 12 points another night and 9 points another night. And after 100 games, he's going to have 100 different point totals. And a measure of center is like a single number that kind of gives you an idea about like roughly how many points he scores each time. Anyways, one of the measures of center is the mean. So the mean is a measure of center in which the average of the data is taken. It can be found by finding the sum of all the data points. So you want to add up all the data points, and then you divide. You're dividing the number by the number of data points. So let's say we've got, let's go ahead and do some examples. The mean can be thought of as determining the fair share of something. So let's take a look at what they mean by fair share. So determine the number of gumballs in each machine. Move the gumballs around to create an equal number of gumballs in each machine. What is the fair share? Or how do they equally distribute the gumballs? How do they get all the gumballs to have the same number of gumballs, machines to have the same number of gumballs is what they're saying. So right now, this gumball, the first gumball has 11. First machine has 11. The second one seems to have 5, and the third one seems to have 8. So if I had 11 in one machine and 5 in another and 8, how do I figure out how many gumballs to put in each of them so that they all have the same number of gumballs? Well, I would do this. I would take 11 and 5 and 8. I would add them up. If you add up 11, 5, and 8, you should have 24, right? So that's 24 total gumballs. And I'm dividing it up into 3 machines. So divide that by 3. And that equals, so I'm going to take that and divide that by 3. So I end up with 24 over 3, which is the same thing as 8. So each machine should have 8 gumballs. If I were able to move them around so that they all have the same amount, then I would make sure that this one has a little bit more and this one has a little bit less. All right, so let's use our understanding of mean to answer the questions below. The list below shows the shoe size for 8 students in Mr. Perdito's class. So we've got a kid with the size 13 shoe, 12, 9.5, 10.5, 12, 11, 12, and 8. So they want us to find the sum first. To find that, we just add them up. So 13 plus 12 plus 9.5 plus 10.5 plus 12 plus 11 plus 12 plus 8. I'm going to use my trusty calculator to do that. So 13 plus 12 plus 9.5 plus 10.5 plus 12 plus 11 plus 12 plus 8. If I add that up, I end up with 88. So 88 is the sum. Now, if I wanted to find the mean, or the average, I have to take all of that and I divide it by the number of data points. So in this case, the number of data points is the number of students whose shoes we have. So that's 1, 2, 3, 4, 5, 6, 7, 8. That's 8 students. So I take 88 and I divide it by 8 and I get 11. So the mean shoe size is 11, or the average shoe size of students in that class is 8. All right, let's try number 2. The following data set represents the age of people in line to vote. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 people here. So I'm going to add all that up and divide that by 10. So if I add these up, by the way, what does that equal? If I add that up, I get 490 actually. And then I need to take 490 and divide by 10. So the sum is 490. Divide that by the number of people, which is 10, and that will get me 49. So the average or mean age is 49. Number 3, the following data set represents the number of times the phone rings when callers contact Link Home Cable customer service. So the number of rings and the frequency. So what this means is like someone tried to call like customer service. They needed help with their internet or something like that, their Link Home Cable internet, whatever. And so they called and it rang 4 times. So 2 people had it ring 4 times. 1 person had it ring 5 times. 2 people had it ring 6 times. 0 people had it ring 7, so on and so forth. So what we need to do is we need to list the data points, because I can't just add 4, 5, 6, 7, 8, or 2, 1, 2, 0, 2, 1. We need to, this is 2 people who had it ring 4 times. So 4 plus 4. 1 person had it ring 5 times. 2 people had it ring 6, so 6 plus 6. Can technically add 12. 0 people had it ring 7, so I don't have to add that. 2 people had it ring 8 times. And 1 person had it ring 9 times. So how many total? This is 4 plus 4 plus 5 plus 6 plus 6 plus 8 plus 8 plus 9. I believe that's 8 plus 5 is 13. 13 plus, that's 19, that's 25. 25 plus 8 is 33. 33 plus 8, 41. 41 plus 9 is 50. So the sum is 50. That's going to be 50, and I need to divide it by the number of data points. The number of data points is not 1, 2, 3, 4, 5, 6. It's the 10 customers, right? The 1, 2, 3, 4, 5, 6, 7, 8. Oh, not 10 customers, but it looks like 8 customers. Thought it was 10. 8 customers. And so 50 divided by 8 should get us 6.25. So the average number of rings one should expect if you call Link Home Cable customer service is it'll ring maybe 6, maybe 7 times. All right, let's try next one. So mean is one kind of measure of center. You find it by adding up all the data points and dividing by the number of data points. Median is the other one, another big one. So the median is a measure of center in which the middle of the data is determined. It can be found by ordering the data from least to greatest and determining the middle of the data set. If there's not one middle number, then find the average or the mean or average of the 2 middle numbers. So I'll give you an example. So we're going to determine the median of each of the data sets below. Number 4 says the following data set represents the number of broken cookies in a test of 9 boxes of Girl Scout cookies. So there are 9 boxes. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9. One of the boxes had 2 broken cookies. Another one had 0, another had 2, then 1, and then 1, 0, 3, 1, 1. Okay, so we need to order these from least to greatest. So the least numbers are the 0 and the 0. So that's the first and second number. So I'm going to cross those off after I list them off. Then I have, next one is 1, 1, ones, and I have 4 ones. So 4 ones, 1, 1, 1, and 1. Sometimes helpful to like put commas between them. And then afterward is 2, 2, 2 twos, and then a 3. So I should have a total of 9 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Good. Now, I need to find the middle number, the middle of the data set. So of 9 numbers, there are a couple of ways to find the middle. But if you may think like, oh, well, the middle of 9 is 5. Another way to do it, if you want to do it physically, is like maybe scratch off 1 from the end. So that's the first number I scratched off. That's 2. Scratched off 3. Scratched off 4. And it looks like this is the middle number right here, the 1. Now you want to make sure it's the middle, because if it's the middle, you should have the same number of numbers on the left and right. So I scratched off 4 numbers on the left. I scratched off 4 numbers on the right. That is the middle. So the median number of broken cookies is 1. Let's take a look at number 5. The following data set represents the number of inches of snowfall within a 2-week period. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data points. It's ordered from least to greatest, so looks like 0 is the smallest, and we have 5 zeros. 1, 2, 3, 4, 5. I'm going to put the commas afterward. All right, and then I have the next smallest number is 1, and I have 2 of those, it looks like. Make sure I have no more 1s. 1.5. Looks like I have a single 1.5, so I'm going to put that next. And then next smallest number is 2, and it looks like I have 2 of them. And then looks like 3. Then 3.5. Hopefully I have enough room. That's an ugly 5, so let's try that again. 3.5, scratch. 6 and 8. All right, so I have 14 data points. You may know that if I have an even number, there's no way that I'm going to have a single number in the middle. There are going to be 2 numbers in the middle. So a couple ways we can do this, but let's go ahead and do what we did before, which is scratch off the end. So that's 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5, 5, 6, 6, and you may say 7, 7. Oh wait, I can't scratch off 7s because if I did, I'd have no number. So I just scratched off 6 numbers on both sides, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I have 2 in the middle. So these 2 numbers are in the middle. And what I need to do to find the median is I need to find the average or the mean of 1 and 1.5. Or if you can imagine what number is in the middle of 1 and 1.5. You may know off the top of your head already. It's 1.25. But if you're not sure how to do it, what you can do is just find the mean. So you add up 1 plus 1.5. And then you divide it by the number of numbers, which is, well, I'm finding the average of 2 numbers, so you're dividing it by 2. So 1 plus 1.5 divided by 2, and that gets us 2.5, and 2.5 divided by 2 is 1.25. So our median is 1.25. So when you have an even number of data points, you're going to have to do this. You're going to have to find the average of the 2 numbers in order to find the median. All right, let's go ahead and look at the next section. Apply the mean and median of the data by answering the questions below. Roanoke Middle School is holding a walkathon, and the top 5 finishers are shown in the table below. So Britt did 35 laps, 33, 33, 32, 30. All right. So what is the mean? Well, there are 5 people. I have to add it up. So the mean, I'm going to go ahead and do this in red. It's 35 plus 33 plus 33 plus 32 plus 30. And you have to divide that by the number of people, which is 5. So 35 plus 33 plus 33 plus 32 plus 30. 163. 163 divided by 5 is 32.6. So that's the mean. Let's do the median now. So the median, let's do that in blue. Order the numbers from least to greatest. So the smallest number is 30, followed by 32, two 33s, and a 35. And we have 5 numbers here, so we should have a middle. So cross those off, cross off another pair. It's 33, make sure it's the middle. 2 crossed off on the left, 2 crossed off on the right. So yes, the median is 33. Are the mean and median close to the same value or very different from one another? What does this tell you about the data? I'd say those two are very close to each other. They are very close to each other. What does this tell us about the data? We could say that there's very little variability between the points. So the differences, we might want to assume that the differences in the number of laps is not very high, and we call that like low variability. But let me go ahead and say that there is. This may indicate that there's little variability. Little variability. What we mean by variability is that like the differences in laps between the top 5 are not very great. Let's take a look at number 7. Mrs. McConnell states that the numbers on the cards below have a mean of 12. What number is missing to make Mrs. McConnell correct? So, well, let's think about this. How do we find mean? Well, we have to add up the numbers, right? 7 plus 16 plus 12 plus 10 plus 11 plus some number. So, if I add them up, they should equal, and I divide by the number of numbers, 1, 2, 3, 4, 5, 6, divide by 6, I should have a mean of 12. So what I'm going to do is I'm basically going to do a, do an equation, make an equation out of this. So I'm going to start off by just adding the numbers on top first. So 7 plus 16 plus 12. 7 plus 16 plus 12 plus 10 plus 11. So 56. So if I added up all of these numbers right here, I will get 56. So 56 plus some number, I'm going to say that's x. If I divide that by 6, I will get 12. So what we have here is actually kind of like a 2-step equation. We want to work backwards. You want to ask yourself, okay, what number plus 56 divided by 6 gets us 12? Okay, so the first thing we did to x was we added to our mystery numbers, we added 56, right? And then we divided it by 6. So we want to do the opposite of it and do it in backwards order. So add 56, then divide by 6, and you'll get 12. Add 56 to this number, and you divide it by 6, that'll get you 12. So I'm not going to add 56. So let's work backwards. The last thing I did was divide by 6. So I'm going to do the opposite of that. I'm going to times it by 6, multiply by 6, and that's going to cancel that out. So I'm going to multiply that by 6, and I get 72. So what that means is if I skip that last step of dividing by 6, then you'll have 56 plus some number gets you 72. And we know how to solve this one-step equation. It's what plus 56. So what plus 56 equals 72? Well, one way of doing this is to do the opposite of adding 56 to our mystery number. We can subtract 56. And when we subtract 56 from 72, we end up finding out that our mystery number is 16. So what that means is if you add 7, 16, 12, 10, 11, and 16, and divide that by 1, 2, 3, 4, 5, 6, you'll get 16. Or sorry, you'll get 12 as your mean. And 16 is that mystery number. All right, so that is measures of center. Go ahead and try some problems on your own. Good luck.